Hello everyone, it's me, Mr. Younger. Today is Thursday, April 9th, and I'm here to do the intro to lab for this week. Waited around a little while. It's about 10:07 now. I was hoping some students might show up and I'd be able to answer questions before I got into the actual crux of the lab. But no one showed up, and that's okay. Y'all aren't required to be here. I'm not trying to cast judgment or say anything bad. I'm just reporting. So today we are introducing you to the latest lab. I'm going to go ahead and share my screen so you'll know exactly what I'm talking about here. It should be actually not that one. I've got to figure out the right screen first. There it is. That's the one I want. So let me kill this real quick. Sorry, I have to do a share again because I had the wrong screen dialed up. Okay, so this week's lab is called Lab 10 PHET Springs, and it's basically the lab report that we do in the 241 course where we actually require a formal lab report. So this is the only one where you're actually going to type up a formal lab report as opposed to just filling in the Word document that we give you. So you can see it's lab 10 springs. It says this lab you'll determine the spring constant of a conical spring using computer graphing as part of your analysis. You'll be given the theory that applies and some general guidelines. The rest of the lab is up to you. You'll have to decide what data to collect, how to make your graphs, and how to present your results. A single report typed with sections detailing equipment, procedures, data, graphs, analysis, and conclusions will be the outcome. And there's basically two types. You're going to use the theory with the static method, where basically you're just going to imagine. In this case, we're going to use PHET as opposed to actually, sending you springs or anything like that. But if you're in a classroom, we would have springs set up, hanged from a module of some sort, and we'd hang weight on it, and then we would look at how much it stretches for a given weight, and then using that we could determine the spring constant. That's the static method. But another way is by realizing once we get into chapter 14, there's a differential equation associated with hanging a mass on a spring, and that differential equation allows you to determine the equation that represents the position as a function of time for a given spring. And in that spring position function, there's a spring constant K, and that makes its way into a period of oscillation. So another method, which is not the static method, but is the dynamic method, that method requires us to look at oscillations of the spring and then use those oscillations to determine the spring constant. So that's what you're going to do. At this point in the semester, you've experienced a lot of ways to do curve fittings, whether they be linear graphs, exponential graphs, uh, quadratic, third order polynomial, all sorts of stuff. And we're expecting that you now are graduated enough from understanding that you can just go on and do your own lab using your own methods and your own uh, techniques of analysis and so on and so forth. So that's what this lab report is actually about. You guys are going to do the static method and the dynamic method and use it to determine the spring constant. And doing that, you're going to sort of make up the lab yourself. The lab report itself, as I said, you will have a cover page. On this cover page, you'll indicate your group, table number, and the list members of your group arranged alphabetically. This is the part where, again, in my class, remember, you not only have to have your name, but you also have to have the names of your lab partners. They're telling you to do that alphabetically. And specifically, I need a clear demarcation as to which one's turning in the lab report and which ones are the partners. So it's not okay to just have the first name be the person turning in the lab and then all the subsequent names being the lab partners. No, I need something separating the two where it shows, these are lab partners and this one's the person turning it in. So make sure you don't forget that part. Don't forget the other rules. No, well, it's normally no black typed font, but if you're turning in an entirely new report, then I don't care about it being black. The purpose, this is a brief statement of what you're trying to determine, also include the theory underlying the experiments. I do want you to do that. I want you to more or less paraphrase, put in your own words, or look in your textbook in chapter 14 and 15. You'll find descriptions, and earlier chapters when we first did Hooke's Law, you'll do descriptions and explanations, or read them about Hooke's Law, F equals kx, and also about oscillatory motion, that sort of stuff. So I would like you to sort of read over that as well as the theory that's listed in this lab report, and then write underlying theory for the two parts of this lab in the purpose portion. So that's something you should write on your own. It shouldn't be plagiarized. It can be paraphrased, and of course, even paraphrasing requires you to cite it. So make sure you cite it. I don't care about whether you use an MLA or APA or any of that kind of stuff. All I need is some kind of citation saying, hey, these ideas came from such and such a write up or from such and such a textbook. You can tell me electronic edition. You can tell me the author, the edition, that sort of stuff. That's sufficient. If you want to use MLA, if that's what you're used to using too, then use MLA. If you want to use the APA, you can do that as well. I don't care, just long as I have a way to locate exactly what you're quoting or paraphrasing. Again, I'm not going to be a stickler about whether it's MRA, MLA, or something. Equipment, please make sure you have a thorough list of the equipment used. In this case, the equipment used is just going to be the PHET program. Having done things with springs already, I suspect you could probably tell us what would normally be used since this is an automated lab. If you were actually doing a non-automated lab, you could tell us the equipment that you'd use. And I wouldn't mind seeing that in this write-up just to give us an idea of what would normally be used and how you're using the PHET in its stead. Uh, Note two different procedures are used in this lab, static and dynamic. You may follow steps 4 through 8, treating both parts together, or you may follow apply steps 4 through 8 to each part separately. Procedure, describe step by step, the data, show all that, analysis, and then the calculation, graphs, and conclusion. So that's the format of the lab report that I want turned in. You have, of course, until 11:59 p.m. 1 week from today to turn that in, and hopefully today I'll be uploading some more grades for more lab reports. That looks like about it. Again, you will be using the PHET website. This is a link to it. Of course, if the link doesn't work, you can still just do a search for PHET yourself. You could at least go to this part and then look for the mass and spring basics, and that should get you to where you're trying to go. So, anyways, I hope that works for you guys. I will be back online tonight to teach. Actually, today is Thursday, so my class normally starts at 5:30, but I normally sign on by shortly after 5 on Thursdays, just in case anybody has any questions. I want to give them more of an office hour, so feel free to show up at any time in that period. Also, at the end of every Monday, Tuesday, Wednesday, Thursday class, the class ends usually by 6:50. I just tell everybody to come in by 6:45, 6:40, something like that, and then at the end, once I'm finished with that class, you can ask questions on any classes, even if it's not the class that I'm teaching then. So remember, that's another office hour. And I hope I get to see some of you at that. And let me know if you have any problems with this lab or if you have any questions. I'll be here. As always, my email I can get, but it's better to text me. So have a good day. See you.